Section 9.9, we're looking at modeling with quadratic functions. In example 1, we have a function where f of t is the number of deaths of motorcyclists in accidents in the U.S. at 2 years since 1980. The data has already been plotted in the scattergram, and our first question is this better to use linear or quadratic? This is definitely better to use quadratic because you can see that the data decreases and then increases. So we're going to use a quadratic model because our data is changing from decreasing to increasing. Next, I want to use my calculator to find the regression model. So the first thing you're going to do is go to your calculator, go to the Stat menu, Edit, enter all of your data. Once your data is entered in List 1 and List 2, you're going to click on the Stat button again, go to Calculate, and do the quadratic regression, option 5. The quadratic regression is y equals 0.019x squared minus 0.6x plus 7.14 with an r-squared value of 0.9758 or 976. Okay, so we have our quadratic model, and explain how you can verify that this is a good model. You can either graph the model on the data and observe that it looks like it fits the data well, or you can say that it has a high r-squared value, and this data does have a high r-squared value. It's very close to 1, so it fits the data well. Okay, let's look at the next page. Find f of 25. What does it mean in this situation? We're going to use our calculator to do that. Let's go back to the calculator. I want to first graph the data. So when you calculate a screen, you want to make sure your plot is turned on, that you have your equation punched in, and we're going to start off with a zoom stat to zoom in on the data. Now that our graph has shown up, if I want to plug a value like 25 into it, I'm going to go second, calculate, choose option 1, value. I'm going to plug in the x value or t value of 25, hit enter. Okay, so in the model, you can see the equation showing up right here. In the equation, a value of 25 for x comes out to 4.64 for y. You're going to get the exact same thing if you substitute 25 for x in the equation and simplify. So please try that and make sure that you do get the same thing. This is the point 25, 4.64. Don't forget to interpret what this means in terms of the situation. So 25 is years since 1980, so that's 2005, and there were 4.64 thousand motorcycle deaths caused from accidents. We can see from our graph that this is an example of interpolation because the value of x equals 25 is inside or in between the data set right here. So this one's an interpolation guess. Remember that interpolated guesses are usually a little bit more accurate than extrapolated guesses. Part F, find when f of t equals 8 by calculator. So I'm going to set the equation equal to 8. So on my calculator, we're going to go back to the y equals menu and let y equals 8 be a second equation, and then we're going to graph again. Now, the equation y equals 8 didn't appear to show up, and that's because my window was not large enough. My y maximum right now is 5, so I need to make that larger if I'm going to be able to see where 8 is. So let's make it at least 10, so it's a little bit larger than 8. Let's graph that again. So there's the data and our curve showing up. In a moment, the graph of y equals 8 will show up. Okay, now it's showing up, but I'm not able to see where they're equal, where they intersect. So I'm going to need to make this graph wider in both directions. I'm going to change the x minimum and the x maximum. The minimum was currently 2, so let's make that say -10, and the maximum was 30. Let's go for 40. So once again, our model is graphing, and the line y equals 8. Now we can see the two intersection points. So we're going to find them by doing second, calculate, option 5 for intersect. First curve, hit enter. Second curve, hit enter. And we're going to move first towards the left intersection point and find that one. So it's at an x value of -1.37. And let's find the other value as well. So second, calculate, option 5 for intersect. First curve, second curve, and then make sure you move to the right. Now we're going to have to move at least as far as the minimum, or it's going to find the one that's closest to it. So you have to move your cursor until you're past the midway point, and then you can hit enter. Now that we're past the midway point, I'm going to hit enter. And the second point is at x equals 31.37. Okay, what does that mean in terms of the situation? So the years I'm counting since 1980, so this is 1.37 years prior to that. So it's going to be in 1978, and 31 years after that, that's going to be in 2001. There were 8,000 deaths by motorcycles in both of those years. In part G, we want to find the vertex of the model. Let's go back to our calculator. And the vertex in this case is going to be a minimum. So we go to second calc, find the minimum value, so option 3, of the curve, that is my function, so the y equals there. I need to make sure that I go to the left side of it first, so click the left arrow until your cursor finally moves over to the left side, then hit enter, and then move it back to the right side and hit enter. And your guess just needs to be somewhere in the middle. Hit enter again, and I found the minimum as 15,2.64. What does this mean? So 15 is years since 1980, so it's going to be in the year 1995. There were 2.64 thousand motorcycle deaths, and because that was the vertex, that is the minimum number of motorcycle deaths there were in any of these years. In example 2, we have data for the median age at which men and women first get married. And the data has already been graphed here, so judging from the data, is it best to use a linear or quadratic function to model the data? They're both quadratic because there's a change where they first decrease and then increase, decrease and then increase. So it's best to use a quadratic model. Part A, we want to find those regression models and find the R-squared values. Your first step is going to be to go to your Stat Edit menu and enter the data for all 3 columns, the year since 1900, the men's data, and the women's data. Now we're going to go to Stat Calculate, and we're going to do the men's equation first. It's a quadratic equation, so option 5 for quadratic regression. Let's write this model down. The R-squared value 0.93 is close to 1, so this should be a good fit for the men's data. Now we're going to find the regression model for the women's data. The data has already been entered into the calculator, but it's entered as list 1 for year and list 3 for the women's data. So when I go to calculate my regression, I'm going to do option 5 for quadratic, but by default it's list 1 and list 2. I'm going to change that so it's list 1 and list 3, second 3 for list 3. So now it's going to calculate using those 2 lists, and we're going to get the regression model for the women's data. Okay, let's write this model down as well. Once again, we have a very high R-squared value, so the women's model also fits the data very well. In part B, I want to graph these to predict when the median age will be the same for men and women. Okay, so let's graph the models. So we're going to enter your model. I've got the full model here. It's not rounded. You can have yours rounded. I need my full model in Y1 and Y2. And I want both plot 1 and plot 2 turned on. Let's go to your stat plot and make sure that they're set up correctly. Second, stat plot. I want the first one to have list 1 and list 2, and the second one to have list 1 and list 3. If the second one doesn't have list 1 and list 3, go into it and change it. Make sure that this one is list 1 for X and list 3 for Y, so you can change those if you need to. Then we're going to graph. I forgot to do a zoom stat, so let's do that as well. As soon as it stops spinning here. Let's try option 9 for zoom stat to zoom in on the data. Men's data is coming out in blue, the women's is going to be in red right below it. See the regression models showing up. And they are pretty close to the data, and the women's model might be just a little bit close to the data. It had a little bit higher R-squared value. Now they're going to intersect somewhere out in the future here, so let's take our window and we're going to change our window to the given window. So we're going to have a 0 for our X-min, 250 for the X-max, a scale of 20. The Y-min is going to be 0. The Y-max is going to be 75. And the Y-scale is going to be 15. Let's graph here. Okay, there we go. We can see the data on a little bit smaller window. And our first model's graphed. Hopefully our second model, we're going to see the intersection of these two. They're showing up right around here. So let's calculate the intersection. So second calc, option 5 for intersect. First curve the blue one, second curve the red one. And we just want to get it close to the intersection before hitting guess. Okay, so the intersection is 198.55, 60.61. This means that 198 years since 1900, or in the year 2098, men and women will both have an average age of first marriage of 60 years old. Now, since the intersection was so far away from where the data was clustered, this is an extrapolated guess and it doesn't seem very realistic. Okay, so that's what the model has predicted. It's possible. It's quite a far distance into the future, so the model may have given us something that doesn't make sense. That's it for this section.